Hello everyone, welcome to Manyam Java Central. Myself Manyam Prasad. In the last session, we have discussed about introduction to Java 8 features in a very high level. And we also discussed a famous interview question, why Java 8? If you didn't watch that video, I have left that link in the description, you can watch it. Now in this session, we are going to discuss about Lambda expressions and functional interfaces. Before starting this discussion, I will tell you why you have to learn Lambda expressions and functional interfaces. You know already every programmer prefers to write his code as per the Java 8 standards. And every programming logic and functionality have been written in Java 8 standards only. Whether that functionality is predefined or user defined, it was written in Java 8 standards only. As I already discussed in my last session, most of the code in Java 8 depends on functional interfaces and Lambda expressions. If you are not trying to learn these functional interfaces and Lambda expressions, even you cannot understand the existing code in your project. If you are not in the position of understanding the existing code, how can you develop your own functionality which was assigned to you? Even in the further releases of Java 8, maximum every functionality depends on functional interfaces and Lambda expressions. Almost for every frequent requirement of the programmer, Java people have provided in the form of functional interfaces. By this, they have removed the boilerplate logic of Java. That is, for every small requirement, the programmer need not to write the code. Rather, he will use the predefined functional interfaces which was provided by the Java. If you don't know the functional interfaces and Lambda expressions, either you have to quit your job or you have to learn them to continue your job. I don't want to quit my job, rather I want to continue my job as a Java developer. That's why I want to learn functional interfaces and Lambda expressions. Learning the functional interfaces and Lambda expressions will take much time. Deep explanation is needed. That's why I need to split this session into two parts. So we will complete this in two parts. See, Lambda expressions and functional interfaces. So Lambda expression. A Lambda expression is a new feature which was introduced in Java 8. Before knowing the Lambda expression, first we have to see the normal and regular function. So what is called a function? A function is a self-contained block of statements. On calling that function, it will do some task. And a method or a function in Java has the below listed main parts. Those are method name, access modifier, return type, parameter list, and the body. Let's see a small function, public int square of a number. So if you observe here, the name of the function is square of number and it has the return type integer. And the same method has a access modifier public, and this function has taken a parameter number which is of type integer, and the same function has a body which was surrounded with a curly braces. Please remember this function, and for now please park this function aside. We will come again to this function. Coming to Lambda expression, a Lambda expression is also a kind of normal method. But unlike normal function, a Lambda expression is an anonymous function which does not have a name and it does not belong to any class. As it is an anonymous, means nameless, it does not have a name, it does not have a return type, and it does not have a modifier. But a Lambda expression might take parameters, and it contains the body which is the main part of the function. The concept of lambda expression was first introduced in Lisp programming language. Lisp is an acronym of list processing. It is a programming language that was designed for easy manipulation of data strings. Similar to other types in Java, lambda expressions are also typed, and their type is a functional interface type. So let's park this functional interface aside because we will discuss about the functional interface after some time. But in order to understand this sentence, let's see the small snippet of code. Int emp number. So here emp number is a variable name of type integer. String emp name. Emp name is a variable name of type string. Like this, employee. Employee is a reference variable of type employee class. Like this, lambda expression type is a functional interface. If we implement the lambda expression, then that type is a functional interface. In detail, we will discuss with example at the time of discussing the lambda expressions. But as of now, you can understand that lambda expression is a type of functional interface. Next, it is very useful in collection library. It helps to iterate, filter, and extract data from the collection. That is, in Java 8 standard code, we have to deal with collections. And at the time of dealing with collections, we need to take help from streams. So the combination of streams with the collections is a frequent requirement. At that time, we have to use lambda expressions frequently in order to iterate the collection objects, in order to filter the objects or extract data from the collection. Frequently we need to use lambda expressions. Without lambda expression also we can achieve our requirement, but without taking the lambda expressions we need to write bundles of code. So in order to reduce those redundant steps, we need to use lambda expressions. See, let's convert the below method in a lambda expressions. See here, in this code snippet, the method name is square of a number, and the function will return the integer type, and the same function has a access modifier public, and this function is taking one parameter, that is a number. This number parameter is of type integer, and the same function has the body which was surrounded with a curly braces. Now if I convert this function into lambda expression, then the result will be like this. So this is a lambda expression which is equivalent to the function shown above. So whatever the functionality this square of a number will do, the same functionality will do by this lambda expression function. See, if you observe carefully, the normal and regular function has three statements, but coming to the lambda expression, if you observe, it has only one statement. Means lambda expressions will reduce the number of steps, means it will provide to the programmer a concise code. So that is the power of lambda expression. Now we are going to see what are the steps we need to follow in order to convert this normal and regular function into lambda expression. So please observe what I am doing. Public int square of number. It is taking one number. I am calculating the square of a number. This function will return square of this number. Now if you observe this function name is name of a square of a number, and the same method has return type integer, and the same method has access modifier public, and this method is taking number as a parameter which is of type integer, and this method has a one statement which was surrounded with a curly braces. Now let's convert this function into lambda expressions. As I already told you, lambda expression is a anonymous function which does not have its name, which does not have return type, and it does not have any access modifier. So now let's remove these three parts. After removing those three parts, the remaining thing is int number return number into number. Next one is, and now we need to tell to the Java that this is a lambda expression. This is done by using a special symbol called arrow operator for defining lambda expression. For defining lambda functions, we need to use arrow operator. Arrow operator means this one. Now let's apply this arrow operator to the above function. Int number, use arrow operator, return number into number. And next one is, if you observe, this lambda expression is taking one parameter number, and this number is of type integer. For the lambda expressions in Java 8, the compiler can guess the type of the parameter. You no need to write the type of the parameter. Just it's enough if you write only a parameter name. Let's convert it. Number return number into number. So if you observe the above step, in the braces you have only one parameter. If you have only one parameter, you no need to take this parameter in the braces. Let's remove that braces also. Number return number into number. So if you observe the above step, in the braces you have how many statements? Only one statement. If you have only one statement as part of your lambda expression, you no need to surround that statement in a curly braces. Even you don't need to write the return keyword if you have only one statement. Let's remove the curly braces and return statement, as your lambda expression has only one statement. Number arrow operator number into number. That's it. This is the final resultant lambda expression. After converting the above function in the lambda expression, the number of statements have gradually reduced, which is nothing but a concised code. That is, lambda expression decreases the code statements and provides more readability. So let's take one more example and let's convert a normal and regular function into lambda expression. Public double calculate perimeter of rectangle int length int breadth. So how to calculate this? Double perimeter is equal to 0.0 d, and next one is perimeter is equal to 2 into length into breadth, and return perimeter. So if you observe here, calculate perimeter of rectangle is a method name. It is returning the double value, and this method has access modifier public. And if you furthermore observe this method, it is taking two parameters which is of type integer, and it has more than one statement as part of its body. Now let's convert the above function into lambda expression. We discussed already, lambda expression does not have a name of the method, and it does not have a return type, and even it does not have a access modifier. If this method is taking only one parameter, so we don't need to write the braces. If it is having more than one parameter, we need to put those parameters in the braces. Let's take length, breadth, arrow operator, and if you have more than one statement as part of your body, then you have to surround those statements in the curly braces. Double perimeter is equal to 0.0d, and perimeter is equal to 2 into length into breadth. Return perimeter. So this is called lambda expression. Now let's see here. Let's see the syntax of lambda expression. A lambda expression is declared by the following syntax. First syntax is no parameter and no return type. First syntax is no parameter and no return type. See the code snippet. So this is a lambda expression, and this lambda expression does not have any parameter, which is having the empty braces, and this code snippet has a body which was surrounded with a braces, curly braces. So in the above syntax, while using the braces, you should have to mind the below points. If there is only one statement in the body section, braces are optional. If you see in this syntax, while writing the braces, you have to put some points in your mind. As part of your body, if you have only one statement, you no need to take the braces, curly braces. As part of your body, if you have more than one statement, you must and should surround those statements using curly braces. See, first one is, if there is only one statement in the body section, braces are optional. See this example. As we have only one statement as part of the lambda expression body, we are not surrounded this statement with a curly braces. Simple thing. And next one is, if there are more than one statement in the body section, braces are mandatory. See, this is the lambda expression. As part of this lambda expression body, we have two statements. The first sysout, in the first system.out.println, we are going to print welcome to, and in the second statement, system.out.println, we have Manyam Java Central. So here we have two statements. So those two statements will be surrounded using curly braces. Let's see the small example. Public void say hello. System.out.println welcome to Manyam Java Central. So this is a normal function name is say hello. So in this function we have only one statement. Let's convert this function into lambda expression. As you know already, lambda expression does not have a name, it does not have a return type, and even it does not have a access modifier. And if you have only one statement as part of your lambda expression, you no need to put that statement in a curly braces. Let's convert the above function into lambda expression. So empty brace, arrow symbol, and directly you can use statement system.out.println welcome to Manyam Java central. That's it. And next one is, if I have more than one statement as part of my body, system dot out dot println, please subscribe to Manyam Java Central. So how many statements as part of this say hello function? 2 statements. So if we want to convert this say hello function into lambda expression, we have 2 statements. Those two statements I need to surround with a curly brace. So write one more statement here. Include here. That's it. It's completed. Now let's see another one. So as part of the first syntax, we have seen lambda expression without parameters, and it's regarding to the how many number of statements. And next one is no parameter with return type syntax. So now we can consider the return type as part of the lambda expression. In this case, if you use the return keyword as part of the lambda expression body, you must and should use the braces to return the value. Means if you want to use the return keyword, you must and should put that return keyword in the curly braces only. If you don't want to write the return keyword, curly braces are optional. See the example for the first point. See, even though I have only one statement, but I have used the return keyword as part of this lambda expression. Then I have to surround this return statement in the curly braces. If I don't want to write return keyword, then you no need to use that statement in the curly braces. See the example. See this example. So as part of this second statement example, I didn't return keyword. That's why I have removed the braces. Let's see one example. Public string request for subscribe. Return, please subscribe to Manyam Java Central. So see, the method name is request for subscribe, and this method is returning the string, and the same method has access modifier public, and it has one statement as part of its body, and the statement has return keyword. Now let's convert this above function into lambda expression. You know already lambda expression does not have a name, it does not have a return type, and even it does not have a access modifier. And if you have only one statement, you no need to take the curly braces. If you want to use return keyword, then you should have to put that return keyword statement in the curly braces. As part of this example, I need to use the return keyword with return statement. That's why I need to put that in a curly braces. So empty brace, arrow operator, use curly brace, return, please subscribe to Manyam Java Central. That's it. If you don't want to use the return keyword, it's very easy. Empty braces, arrow operator. If you don't want to use return, just you have to use that statement without the return keyword. Please subscribe to Manyam Java Central. That's it. And next one is, the simplest lambda expression contains a single parameter and an expression. So see what is the simplest expression contains. See the example. See the syntax. So here I have only one parameter. You know already, if I have only one parameter, braces are optional. Or if you want to take that parameter in braces, it is not a problem. So compiler will always accept it. But it is up to you whether you have to take the brace or you want to remove that brace in order to put your parameter. But to use more than one parameter, you have to take those parameters in a brace only. See here, I have two parameters and use those two parameters in the braces. Next one is, in order to do more complex operations, a code block can be used with curly braces. If the lambda expression need to return a value, then the code block should have return statement. Third point says is, if you have more than one statement, you should have to take those statements in a curly braces. And if you want to write the return keyword, you should have to surround that return keyword statement in a curly braces. Otherwise, you no need to use the return keyword. See this example. In the braces, we have two parameters. And if you observe, we have more than one statement. Those statements are surrounded in a curly braces. Let's see the small examples which will support 1, 2, 3 points. Public int show number of likes, int n, return n. So here show number of likes method is returning the integer value, and the same method has access modifier public, and this method is taking a parameter n which is of type integer, and even it has one statement which was surrounded in a curly braces. So this statement has a return keyword. Now let's see how to convert this above function into a lambda expression. So simply take a parameter name, arrow operator, that's it, completed. And if you want to take the return keyword, if you want to write the return keyword, you must and should surround that return keyword in a curly braces. That's it. And even if you want, even you can take that parameter in a parenthesis. That's it. And even for this, you can use return keyword, return n. That's it. That's it. Next one is characteristics of a lambda expression. First one is type declaration, which is an optional. You no need to declare the type of parameter. The compiler can inference the same from the value of parameter. Second one is parenthesis around parameter, which is optional. You no need to declare parenthesis for a single parameter. For multiple parameters, parentheses are required. Curly braces, which is optional. You no need to use curly braces in a function body if the body contains single statement. Return keyword, which is optional. The compiler automatically returns the value if the body has a single expression. Curly braces are required to indicate that expression returns a value. So now quiz time. Get ready for challenge. Confirm the valid and invalid declarations of lambda expressions. See the first option. If you observe carefully, this statement is having the return keyword. But when can we take the return keyword? So return keyword, if you use the return keyword, that return keyword must and should surrounded with a curly braces. But as part of the first option, you are not seeing any brace, curly brace. That's why this first option is invalid. Let's see the second option. So the second option is having return keyword, and that return keyword was surrounded with a curly braces, and even that statement has been completed, which has ended with a semicolon. So which is valid option. See this third option. So third option has a return keyword which was surrounded with a curly braces, but the statement was not completed. means you are not seeing any colon after the written statement. That's why it is incomplete. That's why it is not valid option. Next one is as part of the fourth option. So it does not have a written keyword and it does not have a curly braces, which is valid option. Coming to the fifth one, you are seeing braces, but you don't have any written keyword, which is invalid. So in this slide, we have already given the explanation as part of the previous slide. Next, let's do some more examples in order to understand briefly the lambda expressions. Public int factorial int number int fact is equal to 1, and for int I is equal to number I greater than 0, I minus, and fact is equal to fact into I, and at last we will return factorial. So this is the small code snippet which will give the factorial of a number. So this function name is factorial and it is returning the integer value, and it has the public and it has the access modifier public, and even this function is taking a parameter number which is of type integer, and even this factorial method is returning a value. So now let's convert this above method into a lambda expression. You know, lambda expression does not have a name, it does not have a access modifier, and even it does not have a return value. Let's see how I can convert this into a lambda expression. Number, arrow operator, and as we have more than one statement, please put that statements in a curly braces. Int fact is equal to 1, for int I is equal to number I greater than 0, I minus, and next one is fact is equal to fact into I, and next you can return fact. That's it. This is all about lambda expression. See, functional interfaces. The term Java functional interface was introduced in Java 8. Before going to discuss about this functional interface, let's see normal and regular interface. Let's revise the rules at the time of creating the normal interfaces and at the time of implementing that normal interfaces. Interface loan specification. This interface contains two methods: void type of loan, double calculate loan amount, boolean is loan applicable for farmer. So if you observe this is a normal and regular interface in Java. Every method present in interface is by default public and abstract, whether you have defined or not. And next one is this normal and regular interface contains more than one abstract method. And next one is, if any class need to implement this loan specification interface, that implementation class must and should provide implementation to each and every method present in that interface. These are the three rules we are dealing with normal and regular interfaces in Java. So let's park this explanation about the interfaces aside. Now coming to this functional interfaces, an interface that contains exactly one abstract method is known as functional interface. So what is this? An interface that contains exactly one abstract method is known as functional interface. By this, you can understand that these functional interfaces can contain only one method. That method should be a public and abstract method. Functional interface is known as single abstract method interface or SAM interface. Because of having only one abstract method, these functional interfaces are also known as single abstract interface. In short, it is a SAM interface. SAM, single abstract method. And coming to the next point, functional interfaces can have only one functionality. That functionality will exhibit the nature of functional interface. So what is this point meaning? So as we already discussed that functional interface can contain only one abstract method. That abstract method will specify the functionality. So based on that method functionality, the name of the interface has been decided. Let's take runnable is a predefined functional interface. A runnable functional interface contains run abstract method. That method is used to deal with the thread, like running the thread, creating the thread, so on. For example, see here, I have functional interface runnable. This functional interface runnable has run abstract method. So what is the use of this? What is the functionality of this run method? So this run method will deal with the threads. It is used to run the thread. So as already you know, this run method is used to running the thread. So this functionality will exhibits the nature of this functional interface. Means the work of this abstract method will decide the name of this functional interface. And this next point is the lambda expression is used to provide the implementation of that interface. So see, for the normal interfaces, who are going to provide implementation? Implementation classes. The class which is going to provide implementation for that interface, that implementation class need to provide the implementations for the methods which are present in that interface. But coming to the functional interfaces, functional interface contains one abstract method. Who is going to provide implementation to that abstract method in that functional interface? Lambda expression. So here lambda expression will provide implementation to the abstract methods of that functional interface. This is very, very important. That's why that lambda expression's type is functional interface. We already discussed this point at the beginning of this session. The lambda expression type is that functional interface. That's why we need to assign that lambda expression functionality to the reference variable of functional interface. So let's wait for some time. You can understand each and everything while implementing the functional interfaces using lambda expressions. For example, runnable, action listener, comparable are some of the examples of functional interfaces. So these three functional interfaces are predefined interfaces. Already these interfaces are defined in the Java language. But unlike these predefined interfaces, every programmer can write his own functional interfaces also. By this you can understand that a functional interfaces can also be a predefined and it can also be a user defined, but the theme is same. What is that? Every functional interface, whether that is a predefined or user defined, it contains only one method, which is abstract method. For that method, lambda expression is going to provide implementation. That is the base point. So see, this fourth point is something, this fourth point will provide something contradiction. So listen, apart from one abstract method, a functional interface can also have the below listed methods that do not count for defining it as a functional interface. So what we can understand is, apart from the abstract method, functional interface can also contain default methods, static methods, and also some of the methods which was inherited from the object class. But these default methods and static methods will not be counted. If anyone can ask what is a functional interface, you can answer, an interface which is having only one abstract method is nothing but a functional interface. This is one of the famous interview question. What is a functional interface? An interface which contains only one abstract method is nothing but a functional interface. And again he will shoot one more question to you. Are you sure functional interface contains only abstract method? But your answer is, of course, functional interface can contain only abstract method, but along with that abstract method, that functional interface might contain default methods as well as static methods, and also few methods which are inherited from the abstract class. The best example for our explanation is, check out the source code of comparator interface. It is a functional interface, but but if you observe the code of comparator interface, it contains two abstract methods. One is compare and another one is equals. So here compare is exclusively written for comparator interface, but equals method was inherited from the object class. That is not counted. Other than the above two methods, all other methods are default methods. So comparator is qualified to be declared as a functional interface. See here, comparator is a functional interface. For this comparator, the abstract method is compare. This compare method is exclusively written for the comparator interface. So this compare method exhibits the functionality of comparator interface, but equals method is not written for the comparator. It was inherited from the object class. Along with these two abstract methods, it has some multiple default methods as well as a static method also. So I will show you the source code of the comparator using Eclipse. See, I will show you the source code of comparator interface. Comparator. So listen, see here, comparator is a functional interface. It is having compare method which was written exclusively for comparator interface. This compare method, the functionality of the compare method will exhibits the functionality of this comparator interface. Next one is, see this equals method. This is also an abstract method. How we have compare method. And the next one is reversed method, is a default method. And next, then comparing is also a default method. And then comparing default method. Then comparing int is also a default method. Then comparing double, also a default method. See here, reverse order is a static method. By this, what you can understand, in comparator functional interface, along with the compare abstract method, I have some other abstract methods which was inherited from the object class, and along with these two methods, a functional interface may contain default and static methods. And next one is, to designate an interface as a functional interface, we need to use the functional interface annotation. But this annotation is optional. But using this annotation is more encourageable. The functional interface annotation prevents the abstract methods from being accidentally added to functional interface. See the code snippet. Square is a functional interface. See this code snippet. Square is a functional interface. How can you know square is a functional interface? This interface containing only one abstract method. So we can say the square is a functional interface. And another main point is, along with that, so to designate the square as a 100% accurate functional interface, we have to use functional interface. This is an annotation which is used to designate the square as a functional interface. But writing this annotation is optional. So in my point of view, using this annotation is more encourageable. Why I am suggesting to use this annotation? See this code snippet. See the situation. After seeing the situation, you only can accept that using functional interface is more better. I have one interface square. As this is a functional interface, I can write only one abstract method. Calculate int x. So we know this is a functional interface. How can we know? This interface is containing only one abstract method. So we can say this square is a functional interface. As I have developed this square, so I can understand that this is a functional interface. But maybe if some other developer can see, he cannot understand whether this is a functional interface or normal interface, because normal interface also can contain one abstract method, or it can contain more than one abstract method. But in this case, another programmer is seeing only one abstract method, but he does not know this is a functional interface. So as he does not know this is a functional interface, there might be chance of adding one more method by him. For example, double calculate int x int y. Now please tell me, is this a functional interface? No, because functional interface does not contain more than one abstract method. But my intention is this square is a functional interface. But after adding another method with some other programmer, the nature of the functional interface of the square has been collapsed. So in order to avoid adding unnecessary methods to this functional interface, you have to use functional interface. Now by seeing this functional interface annotation on top of the interface, if any programmer can see this functional interface, he can understand that this interface is a functional interface, and he will not add any more methods to this functional interface. So this is one of the advantages of using functional interface annotation. Lambda expression with functional interfaces. As I already discussed with you, what is the use of lambda expressions? Lambda expressions are used to provide implementation to the abstract methods of functional interfaces. Lambda expressions are the type of the lambda expressions are functional interfaces. So you can understand that if there is no lambda expression, we don't have functional interfaces. If we don't have functional interface, writing the lambda expression is waste. That's why lambda expressions and functional interface will go by hand in hand. So see, to use lambda expression, you need to either create your own functional interface or use predefined functional interface provided by Java. Lambda expressions can only be applied to abstract method of functional interface. If you want to invoke lambda expression, compulsory functional interfaces are required. The lambda expression is used to provide the implementation of an interface. See this. This is a functional interface. Square is a functional interface. How can you know this is a functional interface? First point is, in this interface you are seeing only one abstract method. By this you can understand that square is a functional interface. And the next one is, you can see here @functional interface annotation is used for square interface. By this you can understand that it is a 100 functional interface. Next, how can we provide implementation to this functional interface? How can we provide implementation to this functional interface? You know already, using the lambda expression, I can provide implementation to this abstract method of this functional interface. After providing the implementation in the form of lambda expression, that lambda expression implementation is assigned to the reference variable of functional interface, because the type of the lambda expression is functional interface. These 2 points you need to remember. What are the 2 points? Provide implementation in the form of lambda expressions to the abstract method of functional interface, and assign that lambda expression implementation to the reference variable of functional interface. Next, see the implementation of this lambda expression. See, square is a functional interface. How can you know this is a functional interface? It is having only one abstract method. By this you can conclude that this square is a functional interface. And also, this square functional interface is annotated with @functional interface annotation. For this abstract method, you have to provide implementation using lambda expression. See, this is a lambda expression implementation, and this lambda expression implementation is assigned to the reference variable of functional interface. And after this, you can call this method, functional interface method, wherever you need. This is the use of functional interface and lambda expression. Without lambda expression, we don't have a functional interface, and without functional interface, we no need to use lambda expression. So create one class functional interface demo. Functional interface demo. So before this main class, I need to create one functional interface. Interface square. So this is having only one abstract method, int calculate, int x. As this is the functional interface, I can use @functional interface annotation. Now write the main method. Write the main method public static void main string array of args. And next one is, take the reference variable of functional interface. Square reference is equal to, provide the implementation to this abstract method present in the functional interface in the form of lambda expression. How can we write lambda expression? X arrow operator, and it is returning x into x. That's it. And you have to call wherever you need. sysout the square of a number is equal to, call that method by using reference variable of functional interface. Calculate 4. Let's execute that. The square of the 4 is 16. Next, write one more example in order to demonstrate the functional interface and lambda expression. Let's take one more example in order to demonstrate the functional interface and lambda expression. Now, in this example, I need to find out the pi value. So for this, I need to write interface my interface. Here, double get pi value. So designate this functional interface using @functional interface annotation. So let's implement this abstract method using lambda expression and assign that lambda expression to this functional interface reference variable. My interface reference is equal to this. How to get this pi value? 3.1415. Just call that method. The pi value is equal to, call that method by using reference variable ref dot get pi value. That's it. Let's execute this method. 3.14. Let's take one more example. In this example, we are going to find out the factorial of a number. Interface factorial functional interface. So in this, I have abstract method public int find factorial int number. So now provide implementation to the abstract method find factorial. Now provide implementation using lambda expression. Let's provide implementation to the abstract method find factorial in the form of lambda expression. Factorial function interface reference is equal to number, arrow operator, and next one is int factorial functional interface reference is equal to number, arrow operator, int fact is equal to 1 for int I is equal to number, I less than I greater than 0, I minus, and fact is equal to fact into I, and here you need to return fact and call that method wherever you need. Sysout the factorial of a number plus reference dot factorial of 4. Let's execute this example. Factorial of 4 is 24. Let's take one more example in order to understand more on these functional interfaces and lambda expressions. So now I need to do string concatenation using functional interface. Interface string concat. So this interface is containing public string yes yes, concat string str1 string str2. This is an abstract method, and in order to designate this as a functional interface, you need to write @functional interface. Let's provide implementation to the sconcat abstract method using lambda expression. String concat reference is equal to str1 str2, this operator, and next one is return str1 plus str2. Sysout result is equal to plus reference dot sconcat hello Manyam Java Central. That's it. Let's execute this. Hello MJC. And next one is more. Let's take one more example in order to understand more about these functional interfaces and lambda expressions. Now we need to do example on reverse of a string. Let's take functional interface my interface. So here I have one abstract method string reverse string n. You can take any variable actually. So in order to designate this as a functional interface, you have to use @functional interface. And let's provide implementation to this reverse abstract method in the form of lambda expression and assign that lambda expression to the reference variable of functional interface. So my interface reference is equal to n arrow operator string result is equal to take an empty string for int I is equal to n dot length -1 I greater than or equal to 0 I minus and result plus equal to n dot char at I return result. That's it. And you can call that method wherever you need. Sysout reversed string equal to plus reference dot reverse of MJC. Let's execute this. CJM, yeah. So that's it. This is an implementation for lambda expression. And next one is very important. So let's take a general function interface with lambda expression. General function interface in this sense. So now I am going to write a generic functional interface which will take any type of class. Let's see here, interface generic interface, and it will take any type. And this interface, functional interface, contains a method that will take any type of class. Here T represents any type, and to designate this generic interface as a lambda as a functional interface, you have to use the annotation @functional interface. Now, so for this abstract method of this functional interface, I have implemented two functionalities. One is reverse of a string and another one is factorial of a number. So for these two functionalities, my implementation is done with using two lambda expressions, and create the two lambda expressions and assign each lambda expression to reference variable of functional interface. So take a first one, generic interface, and this will take string as a type, reverse is equal to str arrow operator, string result is equal to empty string. For int I is equal to str dot length -1, I greater than or equal to 0, I minus. Result plus equal to str dot for int I is equal to str dot length -1, for int I is equal to str dot length -1, I greater than or equal to 0, I minus. Next one is result plus equal to str dot char at I. Next one is return result. So this functionality is completed, and you can call that functionality wherever you need. Sysout reverse of string is plus reverse dot function mj. Next I need to do one more functionality, which is to calculate the factorial of a number. Generic interface, this functional interface now will take integer factorial is equal to n arrow operator int fact is equal to 1. For int I is equal to n, I greater than 0, I minus. And next one is fact is equal to fact into I, return fact. So you can call this functionality wherever you need. Sysout the factorial of 4 is plus factorial dot function of 4. Just execute that. So see, reverse of a string is CJM and factorial of 4 is 24. By this I can complete this session as a part 1. You can consider this session as a part 1, and now as part of session 2 I can cover some more concepts of lambda expressions and functional interfaces, like implementing threads using lambda expressions, and anonymous inner classes versus lambda expressions, and functional interfaces with respect to inheritance, and how can we use lambda expressions for collections. And we will do some of the examples on how to create a thread using functional interfaces and lambda expressions. And we are going to discuss what are predefined functional interfaces, and we will learn types of predefined functional interfaces, and we have to know about what is predicate, what is consumer, supplier, and function. So until then, stay tuned to Manyam Java Central. Thank you. So please subscribe, like, and share. If you feel this video is worth for watching, please share this video to your friends who are struggling for learning functional interfaces and lambda expressions. Thank you. Thank you very much.